and we have a camera set up in the corner here for interviews. Take it away, Derek.
So I'm standing here with Reese, who just finished up his run from Case Western University. Reese, give me some of your thoughts about your run today, how it went so far.
Well, overall, part of being an engineer is being honest, and that was not exactly what we wanted to see in the arena. We've had a test run previously that went stronger, and we had an error where the robot got stuck in a hole. So initial locomotion performance was really good, the robot was reconfiguring itself, and our code was working well. Sometimes a failure comes down to operator error. You're talking to the operator right now, so there we go, no accusations made, other towards myself. That being said, I think we have the potential for a really strong second run, and everything was running. Is ultimately, we fell into a hole that we couldn't get out of, literally in this case, but the robot's looking great. I think we're gonna get a good second mining run. So,
how long did your team work together to build a robot, design it, construct it? Just talk to me about the overall process of getting here and the amount of work and effort it took to design such a technological advancement, you know?
Building a robot, I mean, on the scale of this robot alone, it's more than a year's work of design, manufacturing, assembly, and working as a team. Although with this competition, every year is an improvement. You take your work from last year, see what you can fix, see what you can improve, what worked well, what didn't, and bring that over to a new stage. So in the same fashion, this robot is both a year of work on its own, and probably it has 4 generations of siblings and lessons learned that have gone into building it. So you can say 1 year, you can say 5, depends on how you look at it. But yeah.
And you guys went with a wheel mechanism instead of a track mechanism. What were some of the thoughts behind that? I mean, what are the pros and cons in your opinion?
That's a huge part of our robot, actually. What we found is that having a robot that's very, very long with a wide wheelbase is very, very useful for the kinds of excavation and deposition systems we use. The problem with that is with a really wide wheelbase, kind of like same as on a car, basically, your turning friction gets terrible to the point that a locomotion system just isn't effective. Our solution for that is we have a pretty sophisticated system. Each wheel includes what's called a wheel pod, so it can be independently actuated, has its own motor. Our wheels are actually vacuum-formed carbon fiber designed with special characteristics to support this kind of motion. Locomotion is huge, and our robot has a really, really unique system out in the field.
So, Reese, are you confident for your next run?
Yes. Ultimately, the variable that needs to change is the operator, so again, I'm standing here, but I think we're going to hit it well.
All right, thanks a lot for your time.
Absolutely.
University, after he finished his first run, Stephen, how do you feel about how things went so far?
Well, that was actually our first test as well as our first run. Going better. Drove it into a hole, we were fine. I think we burned out our front left bag motor. So,
will you be ready for your next turn?
I think we have some spares, so we may be able to get that on in time. If that's the case.
Having the opportunity to have possibly your robot used for deep space exploration in the future, how does that make you feel?
Well, that'd be pretty interesting to see. We have a pretty redneck robot, so.
All right, how long did the team work together to design, the engineer, and come up with the idea for your robot today?
Well, that's an interesting story. We were working with another team, and we ended up having to redesign the robot in 2 weeks, and we built it in about 1 week.
Well, we look forward to seeing you on your next run. Hopefully you get your robot repaired and back up to a good standing, and thanks for coming out.
Thank you.
Guys. All right. While Colorado School of Mines and Embry-Riddle Aeronautical University